Starting today, we are going to get serious, right? Now we are. You have more or less understood, or at least have a knowledge of where you can find for the data of the so-called empirical regularities. The fact that the economic machine or the collected machines of the global economy are heading towards somewhere. And now we will start school by school in trying to make a sense out of the data and study the theories behind them. Now what I shall do, first of all, I'm going to wrap up this algebra that we have gone through on Monday, put the final touches. And since that was a prelude to the neoclassical model with neoclassical assumptions, then I'm going to set forth the formal way of looking at things. Now, here is what we had arrived at. The basic distinction in neoclassical theory between exogenous type of growth, that is Solow, Phelps, Cass, Koopmans, Uzawa, versus endogenous growth, Romer, the Nobel laureate, Charles Jones, Uzawa, again, Arrow, Prescott, and Lucas. The main distinction is on their thinking of the role that capital plays in modeling. Buyurun, hoş geldiniz. Now, in the neoclassical world, capital is a produced factor. It is saved and invested. And typically, as in our Korn model, it is part of the single output world that we are dealing with. So even though we talk about capital, we rarely think of it as a consumption good versus a savings good, or we rarely distinguish between a consumable good and capital good. And that's the most unrealistic part of the modeling. But what it does is that it leads to a path where you have to be in an exogenous world, because any sort of growth that is based on capital accumulation will be subject to diminishing returns. Because capital, as a factor of production, when applied in constant terms to land and labor in available constant supply, the returns to capital will be decreasing over time. Therefore, the motivation for investing more and more will go down. Classicals, Marx in particular, mentioned this in terms of declining rate of profit due to various other reasons. Ricardo mentioned declining in the rate of return to land, again for various other reasons. But neoclassicals assume diminishing returns to capital when labor is constant. Therefore, the returns to capital falls and the source of growth diminishes over time. Meaning that you have to have an exogenous kick to your system for achieving growth. Capital accumulation cannot be the main source of growth under an exogenous growth model. That's the main distinction, and now we are going to come to that. Even so, when we go back to our infamous question, why are they so rich Why are we so poor, or vice versa? What explains the per capita income differences across nations? The neoclassicals, one by one, eliminated variables. They have eliminated population growth, technology, institutions, ability, and finally, they realized that some people are rich today because they have saved and invested back then, a century ago. Their saving rate was high. They have more investments, and today they have more capital. Poor nations could not have saved enough because they had limited income. Thus, they have less capital. So those people who are poor are because they lack capital. Those people who are rich because they have more capital. And the only way to acquire capital in this world is through saving rates. Therefore, the difference in per capita incomes of rich and poor countries finally is a factor of their saving rates to the power alpha divided by 1 minus alpha if we are operating through a Cobb-Douglas production function. Alpha in the Cobb-Douglas production function narrates the share of capital income in total output. And we are going to use this over and over again. Alpha is not a simple, naive parameter. It is not an engineering variable as it is. Alpha has a very important social role in economics if you happen to use the production function. Alpha denotes returns to capital times capital divided by national output. That is profits divided by income. And this is called capital share. And if we have two factors of production, 1 minus alpha becomes the labor share. Now, as I indicated, there is a legend out there that alpha for a bunch of OECD countries is 1/3, and 1 minus alpha is 2/3. The data does not say so, but as the number pi, 3.14, economists, when they are making back of the envelope rough calculations, tend to take alpha as 1/3. But then we have come to the conclusion that if alpha is a small number, as this thing, putting in the data, the differences between average income of the rich versus average income of the poor turns out to be very small. Even though the saving rates differ, well, the upper bound is 100% or 99.9%. You have to eat something here. So how big can a saving rate be after all? So this difference in saving rates cannot explain the observed income differences across the world. Now, I have just roughly sketched a couple of instances of data. I have taken the saving ratio out of GMP, the level of GMP itself, that is my Y, and I have taken US data. In the United States, This is average saving rate. Household saving rate is almost zero in the United States, 1%, 2%. Why should you save if you are an American? You have dollars. Bernanke had been pouring on trillions of dollars and putting in your pocket, and it is being purchased by us people. And they have a fairly working social security system, retirement funds, and everything. So saving rate is typically very low. But this includes corporate savings and government savings and financial savings as well. Back in this is 2000 data. Income is 35,000. This is income per capita. And underneath, I'm going to take any country, let's say country, anything you want, divided by SUSA, and the implied YR over YP, applying this formula, that is seeing this data, treating alpha 1/3, okay, and seeing this data, and then I will check it with actual data. So for example, let me take Brazil. Their saving rate is 19.7. Income is 7,050 something. The saving rate difference is 1.36, and implied ratio will be 1.144, but the actual ratio is 0. Let me write this the other way around. Y poor divided by Y United States, or Y country. Let's correct this. That is income, per capita income of Brazil divided by per capita income of United States. If you plug these numbers, 1.36 to the power alpha to 1 minus alpha, Brazil should be 1.1 times richer than United States, according to the formula, because they have a higher saving rate, you see. But the actual is, of course, the other way around. I have Turkey for you. Back then, we have had a 16.7% saving ratio, and our per capita income was 6,000 something. The difference will be, since we have higher saving rate, the implied figure is that we should have more income than the United States, but actually we have about 18% of the United States data. This is not very appealing. So, first of all, I want you to continue this exercise. I have prepared for you a very simple homework. Just you are going to fill this sort of a table. You know the address where you can pick up yarısını bu tarafa vereyim. Terkini alayım. This is for next week, next Wednesday. You are going to apply the formula. Take United States per capita income data, and for the saving ratio, now this is crucial and funny. For saving ratio, I will advise you to take the share of gross capital formation in income. Gross capital formation means gross investments. Remember, you are in the neoclassical world. So saving ratio and investment share number should be the same. So rather than searching around what's the saving rate here and there, go back to the PWT data set and take the gross capital formation share in GDP, that column. The acronym is CSH, that is current share dash of investment. Take that column. For this exercise to be meaningful, I think you should take the saving rate as early as possible from 1950s, because it is the end result of that savings behavior that carried away of its implications for today. Today, United States is rich because back then they were patient, they saved, they have invested, they have accumulated capital, and now they are enjoying the richness that they deserve. So go back to that data set, take the saving ratio from the table. Back in 1950s, for United States, take the GNP per capita in US dollars, and then add to me how many countries did I say? Add at least 10 countries of your choice. I am not saying this or that. Try to be interesting. Do not take countries like Hong Kong or Singapore, or the fact that you live in Turkey. Do not take Turkey. I mean, that's. Try to capture interesting differences. Brazil is a nice country. Korea is always interesting. China, well, if data exists and is reliable, it's an interesting anecdotal story. And write a simple essay on how would you predict and how would you close what the theory implies and what the actual data is. Okay? Buyurun.
Can we construct a model to estimate the actual?
No. The actual data is given to you. Just work as a computer scientist. Just fill out the table and tell me what you have seen. If you get these sorts of numbers, then it's trouble. But then, as I mumbled a few words in the last few minutes of Monday's class, then grab a chair, put some light music, your favorite one, open up your favorite drink, tea, coffee, something more harder or softer, and relax and think. That is, become an economist and imagine how you will solve this problem. Saying that, well, this is a piece of crap, we are wasting our time, the whole neoclassical theory, what we have learned thus far from Karl Menger, Walras, and Jevons beyond, the Jevonian revolution, the birth of the neoclassical school, supported by Samuelson, Keynes, and all the big guns, is rubbish. I don't believe in this. I should have been a musician. Do not give up your profession. So go back to work, just concentrate. As we talked about it, we realized that one way of improving the narration, the narrative powers of this formula is to play around with alpha. As I said, it's only a fictitious deity that alpha is 1/3. And one of the problems is because I'm not saying that numbers are telling a lie, or I mean, that's not a course in ethics. It is very hard to come up with a return to capital because we do not have a precise description of what capital is in real life that is relevant for us as economists. Economists had a vague idea of what capital is. And whenever I mention capital, I simply say something like machines, tractors, buildings, highways, roads, depots, harbors. And then you may start adding good institutions, good governance, social capital, historically reliable behavior. As you will see in the empirics of this literature, people started adding things like distance from the equator. The farther you go away from the sun, the more civilized you are. You know, civilization escapes the sun. So the sun is the center belt of our planet. So distance from the equator is investigated as a possible source of an inquiry of the per capita income differences. The alphabet that you use, Latin versus Cyrillic versus Greek versus this and that, components of your land, the biodiversity, so on and so forth. So all of these, alphabet, social history, the number of poets that you have, the number of musicians, social capital, the number of educated personnel, average years of schooling, all of that will be added to the capital stock. And finally, if we increase this number, as we have found last time, the gap between richest and the poorest nations all of a sudden start to open up. So one way of doing this is through redefining capital. And that's what we shall be doing over the next phase of the course. Anything until this point? We are dealing with pure data, real world, confronting data with ideas for the moment. Okay. Now then, as I said, let's be serious about this thing, okay? And let's state formally, what is it that we are trying to find out, and what are our instruments for this pursuit? We are trying to find out the nature of per capita income differences, and in the neoclassical world, an extension of this story, how do we go there? How do we pass through time in equilibrium? What is the adjustment mechanisms that a market economy go through to achieve long-run steady state, that is long-run harmonious equilibrium? And to do so, we need, first of all, observations of long-run equilibrium. That is, what are we trying to explain? Nicholas Kaldor, the Cambridge economist, in his 1961 paper, come up with a number of observations that he called stylized facts. And since then, this has become Kaldorian stylized facts. What he had claimed is that when we observe the then advanced industrialized market economies as an economist, said, I have a couple of stylized observations to make. I am not explaining them, but this is a puzzle. They seem to be shared by the post-war, that is, since roughly 1950 onwards, state of the world. The first thing is that capital output ratio is roughly constant. Alpha. Okay. Sorry, V, capital output ratio. Over a bunch of countries over years. Secondly, that share of labor income and therefore capital income. Also capital income, that is WL divided by Y, or rate of return to capital divided by Y. Wage rate times labor, wages, share of wages in GDP, share of profits in GDP, again, roughly constant. Factor income shares, roughly constant. And all of a sudden, you say, yippee, we are eligible to use the Cobb-Douglas function. Because K to the alpha, alpha is share of capital income, 1 minus alpha. They are parameters. They are not subject to T or I or J or K. Parameters are parameters. Share of labor income and capital income had been roughly constant. And all of a sudden, Mr. Cobb and Mr. Douglas becomes famous. Because the production function they have originated can capture this thing directly. That's why they are so popular. But interestingly, we see that wage rate is increasing over time. Is increasing roughly at the same rate as Y. Well, of course, otherwise this share cannot be constant. Okay. Now, these are referred to as stylized facts of Kaldor. And the idea had been so popular that since then many people had invented a couple of observations and put their names in front of it. My take is Erinç Yeldan stylized facts is something that perhaps not so relevant for this course, but I have my own stylized facts. Everyone has. Prescott and Parente, the previous Nobel laureates about 10 years ago, they have their development facts. Prescott development facts, where one of the crucial idea was that there had been miracles in growth and there had been disasters. That the world is very heterogeneous. That there had been miracles like Japan, Korea, and now China and India, if you will. And there had been disasters like Sudan, Libya, Mozambique, Ethiopia, Tevye. But Kaldor's stay intact. Now, to be able to explain these facts under a neoclassical tradition, we have to start by first a neoclassical production function. A function of technology, capital, and labor. And since it's a neoclassical production function, this thing has to be of constant returns to scale. It has to be of constant returns to scale because it is only the constant returns to scale type of functions will exhaust the value of GDP when factor shares are distributed. In mathematics, the value of the GDP calculated from income side, wages plus profits plus rents plus interest income if you have banking sector plus government taxes if you have a government putting its affairs everywhere. But we don't have the rest. So in our world, there are only two factors of production. And wage rate and rental rate or the profit rate on capital are returns to those factors. Wages plus profits should be equal to the value of GDP. This is true only for constant returns to scale functions because under the rule that each factor is paid their marginal product, that is, wages are paid their marginal product, which is the derivative of this F, capital F, with respect to labor, times L, plus the derivative of this F with respect to K. This is the marginal product of capital, which neoclassicals argue that is equal to the profit rate. Marginal product of labor, the derivative of the production function, is equated with the wage rate. So marginal product of labor times labor plus marginal product of capital times capital should be equal to the function itself. And this is itself the GDP. Do you remember this rule? I forgot, what was it? Euler theorem. The sum of the first partial derivatives of variables sum to the functional value itself. It has nothing to do with economics. The sum of the partial derivatives weighted by the variables add up to the value of the function itself. The partial derivatives, marginal product of labor, the wage rate. If you don't have constant returns to scale, this equality does not hold. And then you are in trouble. Someone is earning a rent or there is a leak out somewhere. The Walras law will disappear. So there is a third factor that is implicitly out there that you are not able to account for. And we don't want that. So the fact that we are working with constant returns to scale production functions is because we want to define GDP as we do in national incomes. Theoretically, zillions of possibilities of production functions are possible. And that had been pursued. But in its bare essence, a neoclassical production function desirably has to have constant return scale, or you will go a lot of pains, like we are trying to confront the data here, in trying to understand why is it, what happens to excess profits, what happens to rents, what is the leak, who is capturing what, what's wrong with the production function, so on and so forth. Okay. Daldınız gittiniz yani bu önemli gelmediyse ama görürsünüz siz. Görürsünüz. All right, the historical importance of constant returns to scale. It's no fictitious nursery school rhyme. It's an important assumption, and you have to stick to it. Well, I'm not going to state it, but you have to we have discussed this or mentioned this. It's obvious. These derivatives ought to be taken. This character has to admit continuity, differentiably continuous, because you want to take derivatives. Otherwise, good idea, but not so useful. So the second thing is these things have to be present. Thirdly, it is ideal that these derivatives, especially this one, has to be of the negative sign. That is, the first derivative should be negative. The first derivative is positive, but the second derivative should be negative. That is, marginal product should be increasing at a decreasing rate. First derivative positive, marginal product, that is, each unit of capital, when added, brings something. It's positive, but it brings less than what it had brought before. It should bring at a decreasing rate. We call this diminishing returns to capital, not to scale. There is constant returns to scale, because returns to scale means if I increase all of these gentlemen here, A, K, and L, by the same amount, then output increases by the same amount. If I increase everything by lambda, all inputs, then output increases by lambda. That is returns to scale. This is if I increase capital only, holding technology and labor constant. Per unit of labor, you are increasing size of capital. That is, the return to that increase is diminishing. So diminishing returns to K and constant returns to scale are two different exercises. They are not in conflict. All right. One, this. Secondly, in this economy, all investment comes from savings, and all savings go to investment. Therefore, savings and investment are identical. Thirdly, we are going to add some notation. We are going to say that L dot over L is constant. That's the population growth rate. And we have A dot over A. That is our Arabic shay. On the other hand, capital stock, that is K dot. K dot is, or L dot is change in K, right? Or in digital world, K dot plus 1 minus KT. And this is equal to investment minus delta K. When I put the dot notation, K dot, meaning change in that variable, L dot is change in variable. L dot over L is the rate of change. So K dot over K will be rate of change of capital. Here I am only referring to as change in capital. So capital accumulates, investment, which is originating by a saving rate on national income, minus depreciation, and we have labor force and technology. Now, let me state the problem, and then we are going to leave it for fertilization until Monday, and then we are going to look at its algebraically. Here is the problem that the Solow, then Phelps, then Cass, Koopmans, and all the way through all the neoclassicals had asked. Here is an economy on three bunch of things. Since we are not able to explain technology, we do not want to make a story out of something that we cannot explain. Saying that nations grow because they advance technologically. Well, how does technological advance happen? It was the first time Paul Romer the Nobel laureate, had come up with a convincing story about how this thing happens. But if you are not using that model, and we have been waiting for about 40 years, from 1956 to 1990, for this explanation, we don't want to deal with something we do not know the reason for at this stage. So I shall simply assume that there is no technical change in this economy. From today onwards, all the way to the day I distribute back your midterms. Then we start endogenous growth for the next 1.5 months. So if there is no technical change, this is what's happening. Factory. Okay. Beğenmedin mi? Neye benziyor? Ha, evet. Ya, burası bacası. Some Chernobyl style smoke. That's the factory. This is what K is. All right. That's what I have in mind. K. And the owner of the factory, our fat guy. And then there are thin guys, workers. Okay. At any point in time, they come together with F, and with given technology, it doesn't change, and they produce Y. But in the meantime, all of these labor, which is growing at the rate N, is fully employed. Now years pass, the size of the capital expands. Okay, there is one more here. This is net additions, K dot, investment minus delta. And also the workers, the number of workers increase. Now, how is it that this extra capital is sufficient enough to employ the extra workers that is coming into the system at a constant rate N, endogenously? Exogenously. What is the market mechanism that enable full employment of labor growing at the constant exogenous rate N, where capital is subject to new investments out of a constant saving rate and subject to some depreciation? It seems that these are different rules of the game. And that was the question, remember? Harrod and Domar said that N S over V, the Harrod and Domar equation, said that capital output ratio, saving rate, and population growth rate are, come on, let's be serious. And these are three different parameters. How come they can be equated at each other at any instant in time? That was their question. And Solow's answer will be in making this V capital output ratio as an endogenous variable within these assumptions, that without any government interference, without any regulation or anything of the sort, if you are patient enough, the market forces will create an adjustment mechanism that at a time where this capital increases by investments minus delta K and increases in labor force by the rate N will be just enough at the exactly correct magnitude in employing this expanded labor force over and in the meantime growing. There will be a full employment, harmonious growth towards the long run equilibrium. And this adjustment is what we refer to as the neoclassical growth model.